Welcome back, generals, to another Let's Fix Generals 0 how to make the best game ever. Okay, so last session we said we continue with this garbage here, so let's do that. Parse function, so there's a to-do filter by text segment, which looks like a reasonable idea. How do we do that? Fix section, number of section. So in the binary we can something with segment, right? Get segment. Name. Oof. Number of sections. Number of sections. Binary dot get section. I don't know why it shows it here at the bottom. What is that? Get section. Is there... Huh, can't get it by index? Get section. Maybe get sections. 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 Plus number of sections. Leave make O binary. Leave make O binary it const sections it section it sections it sections. What is in there? Segments. Has segments. Has segments. Segment. Yeah. There we go. See. Segment, and that returns a segment. Segment command. Leave make O. Oh, segment command. Well, that's unexpected. Segment command. What does it contain? Segments. Segment commands. Maybe we just check segment name. So we say if segment name equals text. Right. Let's see if that works. Let's see. Then we would need this. Let's see. Let's put a breakpoint here. Okay, this one doesn't work. Similar section. Well, we can put this here. Yeah. Suffix section is that. We can this here. Oh. Okay. What? Okay. Something went dangerously wrong here. What happened? Okay, so somehow this breakpoint is not set. Why not? Okay, so number of sections is 1. Yeah, and so this refers to sections, container. Text. Binary sections 25. Text 0. I'm a bit confused about this here. Why? I would have expected that we can increment this segment name. Okay, so anyway, so this one needs to be like that, but how do we correctly increment this iterator? Operator plus advance operator plus n difference. So it must be this one here, but somehow we are not seeing it. Why not? I don't understand. Number of sections is 1. So binary sections 25. Okay, let's check some more. 14. Ah, okay, it does point to data now. Okay. Yeah. Now the question is the calculation correct or not? To fix section. So it's an ordinal. Ordinal. So it's +1. So maybe we need to deduct 1 minus 1. It's possible, yeah. Yeah, could it be that we have to say this minus 1? I think, like this. Let's see. IT pointer text. Text. Then I will go in here and find something. Yeah. Okay, so this looks good. Let's see if that runs through without errors. Yeah, it does. Okay, that's good. Okay, so I think this is correct. And then basically what we do here is we do the same thing, but we use data. And we need to pass a binary, which we do here. Pass variable, binary, pass variable, binary. Sorry about that. Okay, I think what we can also then do is here variable counts 0, yeah, and here at the end we expect that variable counts equals address equals address to I think we are looking for name. I think we are looking name to variable index. Address. Name. Yeah, so the name to variable index. Yeah, I'm not sure. What was the reason that address to variable is so much smaller? Let me see how this was set here. Pass sim. If find address. Oof, I already forgot what is going on here. Okay, so we add, so this one is so 3114 is definitely the amount of variables, yeah. And this one as well, name to variable index. Yeah, and they're all unique names, yeah. Yeah. So we should be able. Yeah. So we should be able to. Yeah, I think what we need to have is variable count here, variable index, but also name to variable index. Yeah, both. So I think we need to fill up the address to variable index because we will get the address from here then, right? So let's say here if parse variable, then plus plus variable count. So variable parse variable needs to return boolean. And there we go, bool. Okay. And I think this one looks correct, yeah. Yeah, okay. Good. Then we return bool here, and then we basically do it the same way we do it here. We remove that and remove that. Okay. For starters, let's copy. Filter by data segment. We have that. By the way, this should be data, and we can stop debugging. Okay, so I think we can remove this and probably also this. Yeah. Okay, so what we do is we have this address here the same way. So we make a const address assert, we remove that. Okay, address to index map. No, we don't use address. We use name. Yeah, I think we use symbol.name. Yeah, symbol name. Cd string name. Okay, and so we're looking for find variable name. How about we just pass symbol name as is? Okay, index t variable index const. Okay, let me say if I probably prefer to do it with the with this here because we also do the same in the other function. Let's use so address to variable index. Now name. It's a multi-map, right? It's a multi-map. Name to variable index. Find name. Address to name to string to index map. Symbol dot name. But that's the index multi-map. Index multi-map iterator. Yeah, but then if but which names were duplicates? hold on. Why are there duplicates? Name to index. Variable index. Huh. Ah. Okay, but then how do we identify it then? If we have... variable name. I'm a bit surprised. There must have been a reason, yeah. Let me... Oh boy. Ah. Let's remove this here. What scenarios? I try to remember. What was the reason we put a multi-map for variables? I would, thinking about it now, I would expect that every variable is unique. There are no duplicates, unless of course they are. Right. Was this when the static is in the header, right? And then it was included in all these different files, CPP files, and then each one has their own copy. Yeah. And then we basically, yeah, okay. Then I think that means we need to have a function that can find the index but hold on. Let's comment return false. Let's comment out the whole thing. Let's compile parse variables. Let's put a breakpoint here. Let's quickly look over our variables to see what's in there. Watch. Okay, let's clean up a little bit here. Okay, so variables. Good. So let's scroll down. Actually, I'm not so sure anymore if it was about that one. I think it was about there was the same variable name twice in a function, right? I think that's what was happening. Yeah. I don't know where to look for it. Uh, okay, I don't see any. Don't see. Here's this one. Okay, but this is not the one that comes a million times. Ah, by the way, there was still this bug that this one is only found once, right? Ah, we'll need to look into that as well. I think. Yeah, I forgot about that. Yeah. Because basic logic frames per second is real. Copy value. So basically, this one exists many times as well. For some reason, we don't see it. Unlike the other one, this one we do get. I don't understand that. What is the difference? Logic frames per seconds. Parse. Parse. Let's do if symbol name symbol.name equals that, int a equals 0, test, create a copy, and logic frames per seconds. Here, copy value. Seconds per logic frame real. Good. Okay, let's put a breakpoint in here. And let's see the difference between these two. Because I would have expected that both of them, both are listed 826 times in CPP files. But instead, it's only one of them and not the other. But they're both showing up everywhere. So what is the difference here? That's very mysterious. Yeah. Very strange. What? Oh. Right. We need to compare that one instead. This one. Well, let's try again. Pass him ends with. Okay, there we go. So this one is one that doesn't show up correctly, right? Let's see. Okay, blah, 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 blah. Context name, 0, blah, description, okay, section, literal. Okay, named variable index name. Data. Okay. Okay. Mm-hmm. 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 And then we go down here and in here. Okay, and then it has an address. Yeah. And it finds it. Yeah. Source file, dig map, yeah. Yeah. Variable. Variance. Variance 1. Good. So that seems plausible so far. That looks good. Okay, what's the next? Okay, so this is the other one. And this one probably takes the same path. Go see it through, yeah, blah. And then it will go in here and then in there and then, yeah, down here. Okay, let's see the next one. Okay, now we got this one again. And I think from now things go wrong, right? Let's see why. So it finds this. Update, yeah. Let's see. Update here. Blah, blah. Okay. Da-da. Okay. Okay. Okay, goes in here and now it finds this address, yeah. Yeah, where? Ah. Right. It doesn't enter because it's not the end. But then, where do we update this then? Hold on. Variance pushback. Variance. Pushback here. Let's see. Okay. So this one finds it. And what about the other one? Let's see. It doesn't. Yeah, finds it. Yeah. And so this one goes in here and then. Aha. So that's a new address. That's even weirder. Okay, I understand the problem. So, or the difference, let's say. So this one here is in many different files, but it always refers to the same address. And this one is in every file, in many files, but it doesn't refer to the same address. Ah, I think I know what it is. Because this one refers to a different section. Right? So this one, we probably find it many times. Literal 4. And so what is this section then? BSS. Okay, so this is the uninitialized section. Aha. I see. Okay, I understand the difference. Okay, that's good. Okay. I see. Okay, so right. So variable indices, source file, source file in this duplicate symbol. Okay, so the implementation is not correct. Yeah, that's what I can already tell. Yeah. Then the question is, how should it be? So duplicate symbol seen inside function scopes. Yeah, I think this happens. Yeah. Address is not 0. Duplicate symbol in a function scope. Oof. Well. Yeah. Yeah, in function we have seen duplicates, but outside of function we haven't seen duplicates, right? Yeah. So I think outside functions we want to have the variance. Yeah. But inside function not. Yeah. Yeah. Oof. Variable index. Ouch. Variable indices. So I think so, maybe we should say or function index is invalid index. And here we say assert it's not invalid index. Yeah. Maybe this would work. Let's see. But then hold on. Variable indices. It would now add a duplicate one here, no? No. This is different source file. Yeah. Okay. And this one, variables, variable index, variable source file. Yeah. Oh, my hand is still hurting. I don't know why. Always hurting. Something is wrong with the hand. It's probably just too much programming. Okay, I think this is safe. This is safe, and this as well. So maybe this is all we needed to do here. Yeah, we should certainly comment this. Within functions, there can be duplicates. But I wonder why that is. Why are there duplicates in functions? That's what I didn't understand. It's really weird. Can we find an example? Maybe. Oh. This is outside of a function, no? You know, I wonder if this means that this is like an inline function. Could that be? This record? So we know that this is a function symbol, and then this is the length of the function, right? What if this record, it's another function, but it doesn't have a name because it's inlined? Could that be? And then these would be like two like inside of this would be this. I don't know, I'm really just guessing here. I have no clue. Can we find more examples of this? Oh. Because otherwise, like these, otherwise make no sense. But maybe they're inline functions. Yeah. But this relatively long here, 60, D9. It's a huge number. It doesn't make sense. D9, 217 bytes. 217 bytes. Is that a lot? Yeah. Let's say instruction is 5 bytes. GCC inline function size. GCC, at which size is it inlined? Do we have to ask ChatGPT again? Yeah, I think we have to ask ChatGPT. At which function size, function byte size would GCC inline functions? What are the rules? Small enough. The maximum number of instructions, not bytes, instructions. Okay. Always inline. Okay, so what is the default number of instructions until inlining is done? 10, 20, 30 instructions. 10, 20, 30. Okay. 30. Okay, so let's assume it is compiled with 03. Yeah. Typical default. Okay, 30. 30 instructions. Let's ask, what is the average x86 instruction byte length? Instruction bytes length. Yeah. 1 byte, yeah, 2, 3, 4, 6, 1, 7, 15. Instructions. The phone number of instructions. Okay, so let's assume. Let's assume an average of 4 or 5. Let's go with 5. It's probably a conservative value. So 30 times 5, F0, 240. Yeah, 240. So what were we looking at? D9. Yeah, it's just below that. I mean, it's borderline. I do wonder. Yeah, let's look at some more values. If you see anything higher than F0. Okay, here are a lot of small ones. Yeah. To me, it looks like it could be inline functions. Yeah. Hold on. But then, so if it has an address, it doesn't have an address. It just has a size. Yeah. Yeah, but maybe it's interesting. Maybe it's interesting. Yeah. To know like how many inline functions there could be, right? Yeah, 13, 19. Yeah, so this one is that's really just my guess here. I'm not sure. But I mean, 15B. It's this one. Okay. D9. E0. That's the highest we have seen here so far. E0. E0 is 224. Yeah. 224. So that's, yeah, 30. Yeah. inlined. Hmm. Hmm. But then is it possible that there, so this one belongs to this, and this would be an inline, and this would be another inline? Two inline functions, could that be? And here would be even more inline functions. Here. Is that possible? I guess it would be interesting to know, like, say, in a... I could also... Maybe it's so... Let me ask ChatGPT about this. I have dumped a MachOCodeGen symbols. I've dumped MachOCodeGen symbols with LLVM object dump, and in the following lists below, in the following list within a compile unit, there are many entries that have just numbers, that have just numbers. Have just numbers. What do they mean? Let's see what the ChatGPT says. I've dumped MachOCodeGen symbols with an object dump. Let's also clarify the command that we have used. Was all headers with the all headers command, and in the following lists within the compile unit there are many. In the following lists there are many entries within compile units that have that contain a number. That contain a number each. A small number each. What do they mean? Yeah. It's marked as D. I wonder what that means. Okay, let's see what he says. The symbols with small numbers, undefined sections suggest that these might be steps debugging symbols, specifically related to n-bin-cl, begin include file, and b-in-cl, end include file. Given that your Mac file contains steps but no dwarf, this aligns with common patterns in older debug symbol format. Small numbers might be file offsets. The small numbers might be file offsets, line numbers, or even checksum values. Compile unit local entries. They may represent source file inclusions. Marking points within the same file. I don't see that. That's 25, another 25. References to external functions or variables. However, in order compile sometimes appear in symbol dumps under undefined sections. Check for, okay. There we don't have this. It's not that. We don't have these. There are no this and this symbols. There are no this and that symbols. Let's ask him, could it perhaps be inlined functions without names? Could it perhaps be related to the size of inline functions without names? Because the second row for the second row is does, because the second row with that does because the second row, because the symbol after the does match the size of the function. The size of the function. Because the symbol after this does match the size of that function, the byte size. Could it perhaps be related to the size of inline functions without names? Let's see what it says. Okay, he's already confirming my bias. Well, it's very likely represent the byte size of inline functions that do not have their own names. They could correspond. Okay, it's just confirming what I am saying. Well, it's not helping. Why they are normally undefined symbol refer to external entities, but compilers sometimes store inline function metadata as undefined since they don't exist as relocatable symbols. Instead, they are referenced inside the contained functions. They are referenced inside their contained functions. To verify that these numbers are inline function sizes, check the disassembly. Byte offset. Oh, that's an interesting idea. Okay. Huh. Why does this have a value here? What is this value for? Is this an address? What is that? It is. Maybe that's just coincidence. Let's see something else. Huh? Polygon trigger. Ah, right. These were okay. Polygon trigger. Right. I wonder if when we generate functions that perhaps we should also copy all these instructions and then put comments where these things are. I don't know if that's useful. Maybe not. I mean, if we look at this, A70. Well, actually, this kind of shows inlining, doesn't it? Yeah, I don't know what to do. I mean, we use it for includes, but maybe there's more we can do here with this information. Okay, but we still don't know what that means. I mean, for 6. For 6 for D. It's unclear. Can there be really so many inline things? I mean, there's so many. Seems unlikely. I don't know. Compare the byte offsets. Well, four, six, 4, 6, 4, 6. Oh no, so what if we take this address minus this address 3a. Okay, I don't think it's related to that then. This one is 7. There's no 7 here. No, okay, so it's not related to that. There's like 225s and yeah, so can it be that this is inline functions somehow? Maybe this one is not inline. Here is not. So here would be another 2 inline functions. The polygon trigger. Can this really be the case? When we pass a function here, pass fun. Let me see. Pass fun. Yeah, so basically, hold on, I have an idea. Let's find a particular symbol. So this one here, this. Okay. Let's say here, if IT name equals this name, yeah. Then we put a breakpoint. So here test, okay. Let's put the breakpoint, and then we step through and see like what happens with the next symbols. Like what values do they have? What do they look like? Are they function symbols or are they something else? Yeah, I think this should help understand. Because if they are not function symbols, then it's probably not related to functions. But if they are, pass sim. Okay. Let's remove these breakpoints. There we go. Okay, that's good. Okay, so let's see. First we pass the symbol. Now we have a function index, and then we break, and then we go to the next loop, and now we should pass the size of it, right? So block end true, and fun index is not invalid, and so it will then do this and then do that and pass all that, and then eventually it will be done, and then it goes down here, resets the index, and it breaks. Okay, now the next symbol. So we are now here. 46. Let's see. Watch symbol value 46. That is. Type is 24, and 24 is is function. It is function. It is a function. 24 function. Yeah. Yeah. Okay. Do we have polygon trigger already in Thyme? It's possible. Probably. I think that's already in there. Yeah. Let me see. Polygon trigger. There we go. Yep, it's already here. Okay, there are a lot of functions. Yeah. Oh, all of these. All of these could be inline. I don't know. Do export. But these would be like, I don't know, a couple bytes only, right? I mean, this looks pretty solid here to me. So there could be inline functions in here, right? Like maybe like this could be an inline function, maybe, you know, maybe. That's not too much. Like, or this one here, maybe, I don't know, something here, maybe not. Yeah, maybe not. Well, it could be. We don't know if it's just... There's so many. That's suspicious things. There's so many. So this polygon trigger, I think that's a constructor, right? Constructor, let's look at it. Oh, there's not much going on. Let me see. Function watch functions. The last function that was added is the destructor. Okay, it's a destructor. Let's look at it in Thyme. But it also doesn't look too big. Can we figure out what this means? So it is a function. It looks like it is a function size. It seems to be well below the threshold for inlining. Most of the time. Sometimes looks a bit questionable. Like E0, that's 225 bytes. It's quite large. Right, so... Yeah. Yeah, I don't know what to say about this. Can it be? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13? 13. Oh, I just realized down here in the tool there's a counter here, 13. We don't need to count by hand. So this is 16. Okay, so there's no relation between those lines and those. Okay. Here we have 2 as well. This function is pretty large. Set point. Set point. Is it in here? Set point. Huh. That seems to be quite small. E2. Oh, hold on. That is small. E2. Okay. But this one. Parse polygon triggers data chunk. There we go. Parse polygon triggers data chunk. Parse. And now I need to always change here the name format because Thyme has it all changed and messed up. Data chunk, that is. Aha. Yeah, okay, so this is big. Yeah, this looks big. I don't know if it is a 4.5. How much is that? A 4.5. What? 2,600 bytes? That is outrageously large. Hold on. Let's jump to it. That is outrageously large. Let me see. So from this address here, save that. Notepad. So from here to, let's see. Okay, yeah, it seems to be long. Yeah, oof. Call data chunk input read end. Yeah. Is that still the same function? Yeah, it is. Holy shit, okay, that is really long. Why is it so long? Ah, there's a lot of inline stuff. Look at this. 3 bytes. Yeah. Okay, here's the end. End. Here. So we're looking at A45. This minus this is A43. Well, it's close. Maybe the end is here. C9. Yeah. That would be A45 then, yeah. Yeah, okay. Yeah, so it's a very big function, yeah. So there is probably a lot of inlining going on. Yeah. Maybe this is related to all this inlining. Yeah. But it could. Data chunk. Polygon trigger seems to be complete. We have well, apart from this function, one function is missing here. Yeah. Yeah, yeah. Yeah, I don't know what to do with this info. What we can maybe do, we just pull it in. And then we keep it. So basically, what do we do? Parse fun. So next fun index. So what happens now? So we go in here, we do this, and then what? It is empty, right? The name is empty. Yeah, the name is empty. So it's a block end function index. Yeah, okay. It's block end. Block end. Block end true. Yeah, how about process? Here at the end of it, down here, where it does this here. Function. Source file index. Yeah, so how about here we say else function size symbol. Let's say named function size info for named function. Yeah. And here we say size info for unnamed / inlined question mark function. Okay. And then we go to inlines. We go to this one, source files. And then we source files, source file, and then function indices. Then here we say function indices. We put a new vector up here, std vector Let's use a uint8 for starters. Let's say unnamed function sizes. Unnamed function sizes. Why do we have no comments here? Functions defined in this source file. Header files referenced in this source file. And this is unnamed slash inlined question mark functions function sizes in this source file. Unnamed function sizes. Then let me put a, now I'm just assume that this is smaller than let's say assert, well, let's say let's put symbol value is a uint64t size. All right, there we go. And make it const. We say size. I just make an assumption. It's smaller than smaller equal ff. Yeah. Okay. And then we say let's just do like this. And then we do here unnamed function sizes dot push back symbol value. Okay. And then we remove this one, this, and that. Size info, yeah. Yeah. Okay, so let's see. Yeah, let's have that run through. I think we need to remove, well, we can have the breakpoint here, that's fine. Okay, let's remove this here, that, and okay. So basically we just collect now these additional information. I don't know what to do with it, but I mean, if it's there and we can collect it, then we just collect it, and I don't know, maybe it will be useful for something, maybe not. Oh, we got an error. Ah, so it's not smaller than that. Okay, what's the size? Let me see. Oh, 2 dB. Wow. Okay, that's big. 2 dB. Okay. What was the last function that we looked at? Let me see. Watch functions. Mac display initialize. Mac display. Yeah. don't have the mangled symbol here. Make this plainish. Well, let's search for Mac display. Copy value. There we go. Okay. Mac display. Mac display. Mac display. Initialize. Can we search in here for initialize? Oh, can't search in here. Well, that's a shame. Okay, but looks like we are somewhere here. No? Mac initialize. Here? No. Yes. This? Oh, Jesus. Here, this address. Yeah, there we go. So what is the value? 2 dB. 2 dB. Here. Oh. Right, we have skipped this here. I see. So we are incorrectly reading this. We shouldn't do that. It's because we do this skipping here. That's why. Yeah. Static initialization. Display initialize. Yeah. I wonder if there's any use with the static initialization. I don't see any use. Oh, they're compiler generated symbols. Does it tell us anything? I don't know. It's always the same bullshit. Yeah, I don't know if this is of any use for us. I can't see it. I don't know. If we go to this one here, what does it give us? Global constructor keyed. Global constructor. Yeah. Let's reference this. Yeah, 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 yeah. Global the audio. Music track field parse table. Music track. Ah. Music track. Music track. G. We get an address. Music track. Music track field parse. G. Yeah. I think what this tells us is that that this thing is definitely initialized in this file, right? This. But don't we already know that? So here we have a G. Game music. Game music CPP. Good. Game music, and here we have this global. And here we are still in game music. L G I don't know if we need that. Maybe, maybe not. It does carry some information, but maybe we already got it all covered through the variable anyway. I'm not sure. Because here we don't have an address, right? Then here we have an address to, what does this refer to? To the value. Yeah, the value, and then, which reminds me, we probably also need to look into assigning values to our variables. Yeah, we haven't explored that yet. So there's that, and there's this, which is the function that initializes it here, which jumps to this one. Which uses this one. Yeah. But I wonder, so if it is marked here, it's marked as G. It's a global symbol. Global symbol. G. Yeah. Music track field path. Yeah. I don't know. I guess it's something we can keep in mind. Yeah. Okay, but currently we skip that. Global. Skip compiler generated. Compiler generated. Maybe global I. Global I. For static variable initialization. Function index, yeah. return. Yeah, maybe. So maybe what we can do is I think the easiest workaround here for this problem is we put a Boolean. I'm just trying to find like the easiest, most elegant solution to like skipping this properly. And I think that is we make a return false here. Right, so we say that we failed passing this, and otherwise here at the bottom we say return true. Always good. And then pass fun here. So we say if let's give it a name. Const bool skipped. Or let's say well, no, that's wrong. We need to invert the meaning. Passed. Well, I mean, let's just say if not pass fun, and then I think we can simply do it plus it, right? So we increment over it. Right, and then here we increment again, so we skip the next line as well, which should be okay. I think. So if we search for global, this global thingy, global, let me see. Maybe I just search wrong here. Here, global, and then below there will be the size. Yeah. Yeah. And here as well. Yeah, I think this is this should be correct. Let's put a few breakpoints here and look through it. Skip function size symbol when skip function size symbol when a function was not passed. Yeah, I think we can also call continue, right? Continue. So if it is not passed, we skip one ahead and then we continue, because we don't need to do. Well, what we can do here is assert. That's a good idea. Assert symbol dot raw type that is expected to be in fun, right? And block end fun block end. By the way, we can also do the following. We can instead say if assert. There are too many asserts than to live. Okay, we expect that the name is empty. How about we put an assert here if if fun index is invalid index, then I wonder why don't we just do it all in one step if it's always afterwards. Why don't we because well, I think it's okay. Yeah. I think this is enough. Yeah. Maybe. Actually, we should probably have an assert here which says either fun index is invalid index or symbol name is empty, right? Or am I missing something? Either the index is invalid or the symbol name is empty. I think that is correct, yeah. Okay, let's see what happens. So many asserts. The more the better. Yeah, the more the better. We want all the asserts, yeah. Okay, so here we have a symbol name is empty, yeah. Actually, yeah. So, yeah, okay, so it's not passed, okay, and so so this one was a static initialization and we skip it, and now we are at something without a name. 24. Yeah. Yeah, let me skip it. Okay. And okay. Right. IT. There we go. There we go. Let's try it again. No, passes, yeah. Good, let's see if that's, no. Oh boy. Parse SOL. Huh. Okay, somehow we broke something. What happened? What happened? I don't know. I did not expect that. Yeah, that is surprising, but there probably is a good reason for it. Let's see. Fun index, yeah. Sol begin, sol end. Do we need to reset something here? Fun index. Yeah, maybe we need to reset these thingies here. Could that be? Yeah, it's possible. Yeah. Yeah. By the way, we can move this guy in here. Yeah, I think we can. Yeah. Because if not pass, yeah. Yeah, I think we need to reset these guys here. Yeah. Yeah, I think that will fix it. Let's try that. Let's see. Oh. Okay, what do we have here? 1d8. Oof. That is pretty large. 1d8. 472. Let's see what it is. Symbol. Pass. Symbol. Watch. Functions. Let's go to the address. Here. Copy value. And there. 1d8, that is. Yeah. and 1 CD. Okay, that's pretty big. Unicode string release buffer 1D8 1 CD 1D8 1 release buffer Unicode string. Could it maybe be jump tables, maybe, or something like that? Jump tables. But it's marked as function symbol. I don't know what it is. Okay, but so it can be. So we should probably uint. Then we need to. Where's it? Here, uint 16t. Name function sizes. Then we make it FFF. Push back. Static cast. Uint 16t. There we go. Let's maybe say uint6 auto size equals that. It's a bit more pleasant to the eyes, hopefully. Okay, then I expect that this passes now. What is the size, by the way? How big is this? Okay, this passes now, yeah. The size is also 16. No. Huh? Variance. Function variance. Yeah, I think we can make this also 16. Let me see. Yeah. We wouldn't save anything, really. Size. We can make it 16 anyway. If the other one is 16, might as well make this 16. Oh, we have 3 more bytes free for something if we want it. Then we can do the same here. I think we can move it out here. We symbol value is smaller than that. And then we move this up here. And then we assign the size here and we push back the size there and boom, we are done. Beautiful. Good. Yeah, I don't know what the unnamed function sizes are useful for, but yeah, it's there, let's say. Good. Yeah. Good. All right. I think we can take a break for now. I think there was one more thing I wanted to document, and that is we want in the variables here to do record for gather initialization init value for static variable. Yeah. Good. Anything else? No, I don't think so. Then, yeah. Hopefully we can get the variables ready for submit. The file is growing. We are approaching 2,300 lines of code. Oh boy. Yeah. Yeah, we still need to do this. So, wait, hold on. Did we now finish? Yeah, we only passed. Yeah, I think we can continue here. Yeah. Yeah, we should be able to continue here. Okay. Then let's put a marker here like that. Okay. Good. Then that was 2 hours, 7. Yeah. Then I will take a break here. I wish you a great day or night. Until next time, goodbye.